Download this code and get free GPT-4o from codegive.com, link in the description below. Structured concurrency in Java, a comprehensive guide. Structured concurrency is a programming paradigm that aims to simplify concurrent programming by ensuring that the lifetimes of concurrent operations are well defined and manageable. In Java, this approach helps prevent issues such as resource leaks, orphaned threads, and complex error handling. Java's structured concurrency features are primarily available in the java.util.concurrent package and the Project Loom initiative, which is aimed at introducing lightweight, user-mode threads called fibers. This tutorial will cover the following topics. 1. Understanding structured concurrency. 2. Key concepts and components. 3. Using Java's structured concurrency. 4. Code example. 5. Conclusion. ### 1. Understanding structured concurrency. In traditional concurrent programming, threads can outlive the scope of the tasks they're supposed to complete, leading to challenges in resource management and error handling. Structured concurrency addresses these issues by enforcing a strict hierarchy in which concurrent tasks are created and managed. ### Benefits of structured concurrency. Lifecycle management ensures that concurrent tasks are completed before the parent task exits. Error propagation, easier to propagate errors from child tasks to the parent. Resource management, reduces the risk of resource leaks by ensuring that resources are cleaned up. ###2. Key concepts and components. ###Key concepts. Task, a unit of work that can be executed concurrently. Scope, a context in which tasks are created and managed. Cancellation, a mechanism to stop tasks that are no longer needed. Error handling, a structured way to handle exceptions and errors arising from concurrent tasks. ### Components in Java. Completable future, represents a future result of an asynchronous computation. Executor service, a higher level replacement for managing threads. Structured task scope, proposed in Project Loom, a new abstraction to manage the life cycle of tasks. ###3. Using Java's structured concurrency. As of Java 21 and the Project Loom initiative, structured concurrency is becoming more integrated. While the full implementation is still in development, we can already see concepts being applied using completable future. ###. Example of using completable future. We can simulate structured concurrency using completable future to manage multiple asynchronous tasks. Java. Import java.util.concurrent.completable future. Import java.util.concurrent.execution exception. Public class structured concurrency example. Public static void main, string args. Try. / execute tasks in a structured way. String result equals execute tasks. System.out.println, final result, plus result. Catch, execution exception interrupted exception e.print stack trace. Public static string execute tasks, throws execution exception, interrupted exception. Completable future string task 1 equals completable future dot supply async dash / simulate long running task. Sleep 1000. Return result from task 1. Completable future string task 2 equals completable future dot supply async dash / simulate long running task. Sleep 2000. Return result from task 2. / combine results when both tasks are completed. Return completable future dot all of task 1, task 2. Then apply v dash String result 1 equals task1 dot join. String result 2 equals task2 dot join. Return result 1 plus end plus result 2. Dot get, / wait for the combined result. Private static void sleep, int millis. Try. Thread.sleep, millis. Catch, interrupted exception a. Thread.current thread, .interrupt. ## explanation of the code. We define two asynchronous tasks using completable future.supply async. Each task simulates a long-running operation using thread.sleep. Completable future.outlive is used to wait for both tasks to complete. The results of both tasks are combined and returned. ##4. Code example with error handling. In a structured concurrency model, handling errors is crucial. Here's an extended example that demonstrates error handling. Java. Import java.util.concurrent.completable future. Import java.util.concurrent.execution exception. Public class structured concurrency with error handling. Public static void main, string args. Try. String result equals execute tasks. System.out.println, final result, plus result. Catch, execution exception interrupted exception a. System.error.println, an error occurred, plus e.get message. Public static string execute tasks, throws execution exception, interrupted exception. Completable future string task1 equals completable future.supply async, dash. / simulate a successful long-running task. Sleep, 1000. Return result from task1. Completable future string task2 equals completable future.supply async, dash. / simulate a task that fails. Sleep, 2000. Throw new runtime exception, error in task 2. Return completable future.outlive, task 1, task 2. Handle, v, x, dash. If, x, equals null. System.error.println, handling error, plus ex get message. Return default result due to error. Return task1.join, plus end plus task2.join. Get, / wait for the combined result. Private static void sleep, int millis. Try. Thread.sleep, millis. Catch, interrupted exception a. Thread.current thread, .interrupt. ## key changes. Added error handling using .handle, which checks for exceptions and allows us to return a default value in case of errors. #5. Conclusion. Structured concurrency in Java provides a robust framework for managing concurrent tasks, leading to better resource management and error handling. As Java evolves with Project Loom, features like fibers and structured task scopes will further enhance the structured concurrency model. By using tools like completable future and understanding the principles of structured concurrency, developers can write cleaner, more maintainable concurrent code. Feel free to experiment with the provided examples and explore further with the upcoming features in Java that support structured concurrency directly.